In the frigid outskirts of our solar system, far beyond the familiar planets, lies a realm of mystery and intrigue known as the Kuiper Belt. This vast region, a cosmic graveyard of icy remnants from the early solar system, is home to a fascinating cast of characters, including the dwarf planet Pluto. Once considered our ninth planet, Pluto, despite its demotion, remains a captivating world, holding court over a system of 5 known moons. Among these, Hydra stands out as a particularly enigmatic figure, a small icy moon locked in a gravitational dance with its distant parent. Discovered in 2005, Hydra's existence hinted at the complex history and dynamic nature of this distant region. Prior to its discovery, our understanding of Pluto's moon system was limited to the larger Charon, a binary companion locked in a tight gravitational embrace with the dwarf planet. Hydra's presence, along with its fellow moons, challenged our assumptions and sparked a wave of scientific curiosity. What secrets did these small icy worlds hold? How did they come to be? Hydra's discovery was not a moment of sudden revelation, but rather the culmination of meticulous observation and a touch of serendipity. A team of astronomers, using the powerful Hubble space telescope, were searching for faint rings around Pluto, a common feature among objects in the outer solar system. They had no idea they were about to stumble upon a new member of Pluto's family. As they analyzed the images, a faint point of light, barely discernible against the backdrop of distant stars, caught their attention. This faint glimmer, initially dismissed as a camera artifact, refused to disappear. Further observations confirmed their suspicions. Pluto had another moon, a small icy world orbiting at a distance of approximately 65,000 kilometers, twice as far out as Charon. The discovery sent ripples of excitement through the scientific community and reignited interest in Pluto and its enigmatic system. Hydra's discovery was just the beginning. This tiny, distant moon, barely a pixel in the most detailed images, held the potential to unlock secrets about the formation and evolution of the Kuiper Belt and the early solar system. Scientists were eager to learn more about its size, composition, and the nature of its orbit. Was Hydra a captured object, a wandering denizen of the Kuiper Belt ensnared by Pluto's gravity? Or was it a primordial relic, a fragment of the same material that coalesced to form Pluto itself? The answers to these questions could shed light on the processes that shaped the outer solar system billions of years ago, providing valuable clues to the origins of our own planet and the countless others that populate our galaxy. Hydra, once an unknown speck of light, had become a key piece in the cosmic puzzle. Hydra, even amongst its celestial brethren in the Kuiper Belt, stands out for its diminutive size. It is a mere speck of light, a cosmic mote dwarfed by the vastness of space. Early observations, hindered by Hydra's immense distance and the limitations of Earth-based telescopes, struggled to accurately gauge its true dimensions. It wasn't until the New Horizons spacecraft's historic flyby in 2015 that we finally got a clear picture of this enigmatic moon. The images beamed back from New Horizons revealed Hydra to be an irregularly shaped body, resembling an elongated potato more than a perfect sphere. Its longest axis stretches a mere 51 kilometers, while its shortest measures a paltry 31 kilometers. To put that in perspective, if Hydra were placed on Earth's surface, it would barely cover the area of a small city. Yet, despite its small size, Hydra commands a powerful presence in the scientific community, its secrets holding clues to the formation of entire planetary systems. The icy realm of the Kuiper Belt is a treasure trove of primordial materials, relics from the early solar system preserved in a state of frozen stillness. Hydra, like its Kuiper Belt counterparts, is believed to be composed primarily of water ice, the most abundant substance in this frigid region. This ice, however, is not the pristine, clear substance we are familiar with on Earth. Instead, It is thought to be mixed with darker, more volatile compounds, remnants of the early solar system's chaotic beginnings. The surface of Hydra appears remarkably bright, reflecting a significant portion of the sunlight that reaches it. This high reflectivity suggests a surface dominated by water ice, albeit contaminated with darker materials. Spectral analysis of the light reflected from Hydra has revealed the presence of organic molecules, complex carbon-based compounds that are the building blocks of life as we know it. This discovery has fueled speculation about the potential for prebiotic chemistry within these distant icy worlds, adding another layer of intrigue to Hydra's story. Hydra's orbit around Pluto is a far cry from the stately, predictable motions of planets in the inner solar system. It is a chaotic dance, influenced not only by Pluto's gravity, but also by the gravitational tug of its larger companion, Charon, and the other smaller moons in the system. This complex interplay of gravitational forces results in an orbit that is both eccentric and inclined, deviating significantly from a perfect circle around Pluto's equator. Hydra takes approximately 38 Earth days to complete one orbit around Pluto, traveling at an average speed of 1.7 kilometers per second. However, due to the eccentricity of its orbit, Hydra's speed and distance from Pluto vary throughout its journey. At its closest approach, Hydra ventures as close as 57,783 kilometers to Pluto's surface, while at its farthest point, it swings out to a distance of 64,738 kilometers. This chaotic dance, while seemingly insignificant on a cosmic scale, holds important clues about the formation and evolution of Pluto's moon system. Like an ancient tapestry woven with threads of cosmic history, the surface of Hydra bears the scars of billions of years of bombardment by asteroids, comets, and other space debris. Craters, ranging in size from small pits to larger impact basins, pockmark its surface, each one a testament to the violent forces at play in the outer solar system. These craters, however, are not evenly distributed across Hydra's surface. The varying density and distribution of craters provide insights into the Moon's geological history and the frequency of impacts over time. Some regions of Hydra appear heavily cratered, suggesting ancient surfaces that have remained relatively unchanged for billions of years. Other areas, however, display fewer craters, hinting at more recent geological activity that may have erased or obscured older impact scars. The presence of linear features, such as grooves and ridges, suggests that Hydra's surface has been shaped not only by impacts, but also by internal processes, such as tectonic activity or cryovolcanism, where water or other volatiles erupt from the Moon's interior. By studying these surface features, scientists hope to piece together the story of Hydra's formation and the forces that have shaped it over billions of years. Hydra, a celestial needle in the cosmic haystack, remained hidden from our view for centuries, concealed by the vast distances and the faintness of its light. It wasn't until the advent of powerful space-based telescopes, capable of peering deep into the cosmos with unprecedented clarity, that we finally caught a glimpse of this elusive moon. In May 2005, a team of astronomers, led by Hal Weaver and Alan Stern, were using the Hubble Space Telescope to search for faint rings around Pluto. They were utilizing Hubble's advanced camera for surveys, an instrument renowned for its high resolution and sensitivity, hoping to capture images of any diffuse material encircling the distant dwarf planet. Little did they know, their observations would unearth a discovery far more profound than they could have imagined. As the team meticulously analyzed the Hubble images, their attention was drawn to two faint points of light, barely discernible against the glare of Pluto and its much brighter companion, Charon. These faint glimmers, initially dismissed as background stars or camera artifacts, refused to be ignored. They seemed to move in tandem with Pluto, their positions shifting subtly from one image to the next. The team painstakingly tracked the movements of these faint points of light over several months, carefully comparing their positions in different images. Their analysis revealed a startling truth. These were no mere stars or artifacts, but two previously unknown moons orbiting Pluto. The larger and brighter of the two, later named Nix, orbited at a distance of approximately 49,000 kilometers from Pluto, while the smaller and fainter moon, christened Hydra, circled at a distance of about 65,000 kilometers. The discovery of Hydra and Nix sent shockwaves through the scientific community, reigniting interest in Pluto and its enigmatic system. These newfound moons, however, remained little more than faint points of light, their true nature shrouded in mystery. To unlock their secrets, a dedicated mission to Pluto was needed, a mission capable of capturing detailed images and gathering valuable data about these distant worlds. Enter New Horizons, a spacecraft designed specifically to explore Pluto and its system in unprecedented detail. Launched in January 2006, New Horizons embarked on a 9-year journey across the solar system, traveling billions of kilometers to reach its destination. The spacecraft carried a suite of sophisticated instruments, including high-resolution cameras, spectrometers, and particle detectors, all poised to unravel the mysteries of Pluto and its newly discovered moons. On July 14, 2015, after nearly a decade of anticipation, New Horizons made its historic flyby of Pluto, capturing breathtaking images and gathering a treasure trove of data about the dwarf planet and its moons. For the first time, humanity was treated to detailed views of Hydra, transforming it from a faint point of light into a world with distinct characteristics. The images beamed back from New Horizons revealed Hydra to be an irregularly shaped body, resembling an elongated potato more than a perfect sphere. Its surface, once thought to be smooth and featureless, was revealed to be surprisingly complex, pockmarked with craters of various sizes and adorned with linear features, hinting at a dynamic geological past. Hydra, once a mere blip on our cosmic radar, had finally come into focus, a testament to the power of human ingenuity and our insatiable thirst for knowledge. Hydra, despite its diminutive size, holds immense significance for scientists studying the Kuiper belt and the formation of planetary systems. This distant, icy moon is believed to be a pristine relic from the early solar system, a frozen time capsule preserving clues about the processes that led to the creation of planets, moons, and other celestial bodies. Scientists believe that the Kuiper belt, a vast region of icy debris beyond Neptune, is home to countless small bodies like Hydra, remnants from the early solar system's protoplanetary disk. These objects, known as planetesimals, are the building blocks of planets, gradually accreting material over millions of years to form larger and larger bodies. Hydra, with its relatively undisturbed surface and composition, offers a unique opportunity to study these primordial planetesimals in their relatively pristine state, providing insights into the conditions and processes that prevailed during the early stages of planetary formation. The formation of planetary systems is a complex and chaotic process, involving the gravitational collapse of a giant molecular cloud, the formation of a protoplanetary disk, and the gradual accretion of planetesimals into planets, moons, and other celestial objects. Hydra, with its unique characteristics and location in the Kuiper belt, offers valuable clues about the specific mechanisms that shaped our own solar system. By studying Hydra's size, shape, composition, and orbit, scientists can gain insights into the distribution of mass and the dynamics of the protoplanetary disk from which it formed. The presence of other moons around Pluto, each with its own unique characteristics, suggests a complex history of interactions and collisions, providing further clues about the processes that shaped the outer solar system. Hydra, in essence, acts as a Rosetta Stone, helping us to decipher the language of planetary formation and unravel the mysteries of our cosmic origins. The outer solar system, far from being a peaceful and serene environment, is a chaotic realm shaped by collisions between celestial objects of all sizes. Hydra, with its cratered surface, bears witness to this violent history. Each impact scar a testament to the forces at play in the Kuiper belt. Scientists believe that the early solar system was a much more crowded place than it is today, with countless planetesimals and protoplanets jostling for position. Collisions between these objects were commonplace, resulting in the fragmentation of some bodies and the accretion of others. Hydra's surface, pockmarked with craters of various sizes and ages, provides a record of these ancient impacts, allowing scientists to study the frequency and intensity of collisions in the Kuiper belt over time. By analyzing the size, distribution, and morphology of these craters, scientists can gain insights into the population of impactors, their compositions, and the effects of these collisions on the evolution of Kuiper belt objects. Hydra's significance extends beyond our understanding of planetary formation and the history of the solar system. The discovery of organic molecules on its surface has fueled speculation about the potential for prebiotic chemistry in the outer solar system, adding another layer of intrigue to this distant moon. Organic molecules are the building blocks of life as we know it, and their presence on Hydra suggests that the raw materials necessary for life may be widespread throughout the solar system and beyond. While the presence of organic molecules does not necessarily imply the existence of life itself, it does raise intriguing possibilities about the potential for life to arise in environments previously thought to be uninhabitable. Hydra, once a mere speck of light in the vastness of space, has become a beacon of hope in the search for life's ingredients, reminding us that the universe is full of surprises and that the boundaries of what we consider habitable are constantly expanding. Hydra, a seemingly insignificant speck of ice and rock adrift in the vast expanse of the Kuiper belt, has emerged as a celestial beacon, illuminating our understanding of the solar system and our place within it. Its discovery, a testament to the power of human ingenuity and our insatiable thirst for knowledge, has shattered our preconceived notions about the outer solar system, revealing a realm teeming with complexity and intrigue. Prior to Hydra's discovery, our view of Pluto's domain was limited to the binary dance between the dwarf planet and its larger companion, Charon. Hydra's presence, along with its fellow moons, unveiled a far more intricate and dynamic system, challenging our assumptions and igniting a firestorm of scientific curiosity. Hydra, despite its diminutive size, became a symbol of the vastness of the unknown, a cosmic Pandora's box brimming with secrets waiting to be unlocked. Hydra's story is far from over. The data gleaned from the New Horizons flyby, while groundbreaking, represents just a tantalizing glimpse into the mysteries this distant moon holds. Future missions, equipped with even more sophisticated instruments and capable of conducting in-depth analyses, are needed to fully unravel Hydra's secrets and shed light on the broader workings of the outer solar system. Imagine robotic probes landing on Hydra's surface, drilling into its icy depths to analyze its composition and search for signs of past or present geological activity. Imagine spacecraft deploying swarms of nanosatellites to study Hydra's interaction with Pluto's magnetosphere and the surrounding space environment. These future missions, driven by our insatiable thirst for knowledge, will undoubtedly unveil new wonders and rewrite our understanding of this distant realm. Hydra's story is not merely a tale of distant worlds and scientific discoveries. It is a reflection of our own place in the grand cosmic tapestry. As we peer into the depths of space, uncovering the secrets of celestial objects like Hydra, we gain a deeper appreciation for the vastness and complexity of the universe and our own humble place within it. Hydra, a tiny world on the fringes of our solar system, serves as a poignant reminder that even the smallest and most distant objects can hold profound significance. It reminds us that the universe is full of surprises, that the boundaries of our knowledge are constantly expanding, and that the quest for understanding is a journey without end. As we continue to explore the cosmos, we do so with a sense of wonder and humility, inspired by the knowledge that each new discovery brings us one step closer to unraveling the mysteries of our existence.